I'm doing great. Thank you for asking. I hope you're doing well as well. So we got a little warm up here. Good morning, everybody. Looks like a lot of people are late today. So we're going to take just a few minutes to work on this warm up. So let's go ahead and say we're going to do 3 minutes for this warm up. So we'll do 3 minutes and then we'll get going. So welcome everybody. We're going to do 3 minutes for this warm up. So welcome people just coming in. We're just working on a warm up. Good morning, good morning. We're just working on a warm up so you guys can get that done. Good morning. All right, guys. So we're going to go ahead and go over this warm up now, and then we have some things that we need to talk about, and we'll jump into finding missing lengths with similarity. Okay. So here, let me get this off freeze really quickly. So again, this is more of what we were working on Monday and Tuesday. So just doing a little review here, and that's proving triangles similar. Okay. So remember, we only have one way currently to prove triangles similar, and that is a similarity. So if we take a look at this picture, you might be like, okay, well, 66 isn't the same as 24, but we have to investigate a little bit more than just looking. Okay, so to do that, we're going to have to use some angle rules that we talked about in first trimester and second trimester. Okay, so first of all, if this is 90 right here, so this is angle FKG, if this is 90 degrees, then what does angle JKG have to be? Right? So how do I know, right here I'm pointing to this angle, angle JKG, what does this angle have to be and why? So what do we got, guys? So what kind of angle relationship would this be, right? So you have to think, okay, so I have a flat bottom here, right? A straight line. So what's the number of degrees for a straight angle? Okay. So people aren't really participating, so that's not good. So it's going to be 180 degrees. Okay, so it's going to be 180 degrees. So this right here is a linear pair. Okay, we need to know that, right? That's what we've been working on quite a bit. So it's a linear pair. So a linear pair, so this means that this is also going to be 90 degrees. Okay, because they're going to add up to 180, right? And 90 plus 90 is 180. Okay. So both of those angles are congruent, right? So angle FKG is going to be congruent to angle JKH, right? Because they're both 90. Okay. So then what we're going to do now is, okay, well, I got a pair, right? So I got this pair and this pair, but we're missing, right? Because 66 and 24 aren't equal. So what we have to remember for any triangle, right? So the angles in a triangle are going to add up to 180. Not the sides, just the angle. So I can go here and say, well, 180 minus 66 minus 90 is 24. So it turns out, right? So this angle right here is 24 degrees. So boom, right there, right? We know that we have another pair. So I know, right, that angle G is going to be congruent to angle H. Okay, and we used triangle sum theorem here. Oops, theorem here. Sorry, I misspelled theorem. I feel terrible about it. So yeah, these two triangles are similar. So we can say triangle FKG is similar to triangle JKH by a similarity. Okay? So just remember, just like the expression, you can't judge a book by its cover, right? You don't want to just look at two triangles and make a judgment call. We have to do a little bit of digging and maybe finding a couple of extra things so that we can say, hey, these are similar. Okay. And as always, if you guys have questions, please ask in chat, or you can turn on your mic and ask that way, okay? All right. And a lot of people came in late today, so I know especially at school it's tough to get from class in 5 minutes, but we do want to try to make sure and get here as quickly as possible. All right, so for this next one, right, so we've seen this one quite a bit, and I keep doing it because it's the one historically that people struggle with the most. So again, we have a bow tie problem. So anytime you have a bow tie problem, you have vertical angles. So I can start by saying, hey, angle LNM is going to be congruent to angle ONP, right? That's vertical angles. Okay, but we also have alternate interior, and we can go angle P and angle M. So I might say angle P is congruent to angle M, and the reason is if parallel lines, then alternate interior angles are congruent. Okay, or right, I could go, oops, I need to get a new symbol there. Okay, so I could say angle L is congruent to angle O, and it's the same reason. If parallel lines, then alternate interior angles are congruent. Okay, now you don't have to do all three of these. Okay, so you don't have to do all three of these. You just have to do two of them. Okay, so so again, I did more than I needed to say that the triangles, so I might say triangle LNM is similar to triangle ONP, and that's by a similarity. Okay, so that's how we do both of those. Okay, and yes, all lessons are always posted to YouTube. So lessons are, right? Lessons are every Monday, Thursday. So with the new schedule, I'm not going to be able to upload until later in the day, but well, maybe for you guys, I should be able to have it up by the end of lunch, hopefully. Okay. Does anybody have questions about these two warm-up problems from what we were doing Monday and Tuesday? All right. So, like it said when people were coming in, today what we're going to be working on is finding missing links with similarity. So you might be like, why the heck are we doing all of this, right? So this is, we're in 8.2 day 2. And we're finding missing links. How are we doing? With similarity. Okay, so that was our title, right? So finding missing links with similarity. Okay, so this is by far the coolest, one of the coolest things. There's a lot of cool things you can do with similarity, but one of the coolest things, and often used, is finding missing links with similarity. And I'm not just talking about any links. I'm talking about links that we wouldn't be able to find without similarity. I'm talking about things where a tape measure just doesn't work. So if you guys remember back when we were doing congruent triangles, I had done the example of finding the distance across the Skagit River. Okay. And I can't remember, was that at the end of last trimester or was that the beginning of this trimester? I can't remember. So maybe some of you saw it, maybe some of you didn't. But we had talked about finding the length of the Skagit River, or the width of the Skagit River. Now, finding the width of Skagit River is not something that you just do, right? It's not like one person stands on the beach with the end of the tape measure and you give the other end to your buddy and you're like, all right, swim to the other side, right? Don't do that. That's not safe. Okay. So how do you do it? Well, you do it by using one way of, well, the best way of doing it is by using similar triangles. So today we're going to look at how we can use similar triangles to measure the length of things that we can't normally measure. Okay. So to start off, we're going to do a classic problem. Okay. So a classic problem is called the flagpole shadow problem. And almost every kid in the United States, or even in the world, does this problem. That's how classic it is. Okay. So basically, it's a bit of a story. Okay. So basically, we have the sun beating down on us. Here, I'll make it a happy sun. Okay. And we have a flagpole. Okay. We have you, or a person. Okay. And now, what does the sun do when it hits objects? The sun creates a shadow. Okay. So what happens is you can kind of, so I'm just measuring the flagpole, not the flag. You can imagine that a ray of sun comes down and goes like this. Or an array of sun comes down and goes like this. And what it does is it creates a shadow on the ground, right? So this is our shadow. This is, well, that's our shadow, right? So the flag has a shadow and the person has a shadow. Okay. How are we doing so far, guys? We doing okay? So what you can see is that these light rays, they create two triangles. Now, you're like, but are they similar, right? Are they similar? So it turns out, so we have to make one assumption, and that is the flagpole is straight up and down, which means this is 90 degrees, and we're going to assume that we're standing up, straight up. So that's 90 degrees. So we have a pair of angles right there, right? We're standing vertical. Right now, you're like, well, what if it's the Leaning Tower of Pisa? Well, then you're going to have to measure the angle. And that's, hey, guys, we have tools to do that. It's all good, okay? But for this problem, just imagine they're standing straight up, so we don't have to measure that angle. Now, to get the other angle, this is where physics comes in. I think this is really exciting. Now, in my picture, see how close the sun is? If you were that close to the sun, we would all be dead, right? So the sun isn't that close. In fact, the sun is really, really far away from us. Okay, so far, in fact, that light coming from it hits this at the same angle that it hits this person. So this angle right here and this angle right here are the same. Now you're like, well, how is that? Well, I can't go too far into it, but imagine you have a curved surface that is the sun, and light shoots off in all directions. That hardly seems the same, right? But then if you go really, really, really far away, so here's Earth. If you go really, really far away, notice how these beams down here, they don't even hit the Earth, right? In fact, there's only very, very few that do hit the Earth. And the ones that do hit the Earth are so close together that they're parallel by the time they get to Earth. They're so incredibly close to parallel. So even though the sun, right, is curved, by the time the light gets to Earth, it's as if the light is coming from a flat source. Now, you're probably like, whoa, okay, that's cool, but what does it have to do with this? That's why these two angles are going to be the same. The sun is going to hit them at the same angle because the sun is so far away, it's like the light source is coming from a flat source. Okay? So, like, people are going to be like, oh, Kreft is a flat sunner. You know, he believes in a flat sun. Well, I mean, no, it just has that effect because it's so far away. Okay? If the sun was flat, we would have some weird things going on with our planet because we'd be rotating around something that's flat. So whenever you went around the edge, bad things would happen. Okay? Anyways, so that's why I hope I did a good enough explanation of this without getting in too much physics, right? Because we don't have the time to go into too deep of physics. But that's why these two angles are the same, okay? Because the sun is in the same position in the sky, hitting these objects from the same thing. Now, if these two people weren't next to each other, then you'd have an argument, right? So, for example, if this flag was in South America and you were in North America, right, then we wouldn't be able to do this. So it only works because they're standing next to each other. Okay. Oh my gosh, you're like, Kreft, get to the math. Well, I just had to set it up. I just want you guys to know that I'm not just making this stuff up. And so let's think about this. Now, in this, we have lots of different measurements. So first, it's going to be really hard to measure this light ray because we can't see it, right? So that's why I kind of wanted to do it as like a dashed line. It makes a triangle, and that's important because we want to talk about triangles. But we can't really measure something that we can't see. So what can we see? Well, things that are really easy to measure. Oh, by the way, I going too fast. Do you guys see how these triangles are similar? So these triangles are similar by AA. Are similar by AA. Okay, so they're similar by AA. That's why I did that whole thing and I didn't say the ending, so that was a little weird. Okay, but there are some things here that are easy to measure. Now, the things that's not easy to measure is the height of this flagpole. It's just too high. Okay, and if you guys, unless you have a really expensive tape measure, it's really hard to get a tape measure to go up without bending over, right? So it's hard to measure this. And I'm picking this, again, this is a classic problem. We can measure things that are much bigger, like skyscrapers and mountains, okay? So you have your height going up like this, okay? Now, we also can measure the length of the shadow really easily, right? You can just have a friend go and measure the length of this shadow, and we can measure our height, and we can measure our shadow really easily with a tape measure, okay? So in this problem, let's say that the shadow from the flagpole is 15 feet, okay? So we get our tape measurer, we go from the base to the tip of the shadow, and we say, okay, 15 feet. And then we quickly, so that the sun doesn't move too much, we measure our shadow. So our shadow is going to be 4.5 feet long. And let's say this person is 6 feet tall to keep the numbers nice. Okay, so here's our setup. These two triangles are similar because they're standing straight up and the sun is hitting them at the same angle. Okay, what we want to do is we want to find the height of the flagpole. So we have to remember now, okay, so these triangles are similar. So then we have to think, okay, so what do we know about similar sides, right? The sides aren't congruent. The angles are, the sides are proportional. So what we're going to do is we're going to start, right? So maybe I should take quick notes on this. So start with the side you are solving for. Okay, so that's step one. So what's the side we're trying to solve for? We're trying to solve for h. So I'm going to write h, right? And then that ratio is going to be, right, corresponding to what? So what does h correspond with in the other triangle? So now what does it correspond with? So yeah, so think of it this way. So these have real things, right? These mean real things. So this is a height of a flagpole. This is the height of a person. So the height should go with the height. Okay, so once you get your first ratio, so second ratio, start with same triangle on top. Okay, so with the second ratio, start with the same triangle on top. So I started with the flagpole triangle on top, so I got to start with that flagpole triangle again. My only other side is 15. Okay, so I'm going to compare shadow with shadow. So the shadow of my flagpole is 15 feet. This shadow of mine is 4.5. And that's it, guys. Once you get this, this is our proportion. Okay, and that's cool that you found scale factor, but we don't really care about scale factor here. We want to find the height of our flagpole. So to solve these, again, it takes nothing fancy. We want to get h by itself. So it's h divided by 6. So all we have to do is undo the divide by 6. So I'm just going to multiply by 6 on both sides. And so we get h equals. Now remember, you can do all of this on a calculator, whether that's a physical calculator or Desmos. I can go a fraction. I can go 15 over 4.5 times 6. Okay, and then I get 20. And then don't forget to add in units. So I know that my flagpole is 20 feet tall. Okay, and once you get the hang of this, it's really easy to do. Now, you might not be impressed with measuring the height of a 20-foot tall flagpole, but what about measuring the height of New Main at the high school? Or what about measuring the height of Old Main at the high school? Or what about measuring the height of a skyscraper in downtown Seattle? All right, or what about measuring the height of a mountain? Okay, so all of these things, it would be impossible to measure it with a tape measure or even a measure of any sort. Okay, now some of you guys are gonna be smart about it, and you're gonna be like, well, what about lasers? Okay, cool. So lasers works, but the way lasers work is that they're waves, and you send out a specific wavelength, and then it hits it and comes back, and so you know the wavelength. And so when it comes back, you can see how much it's offset. So there's two ways you can do. You can do like a radar, where it sends a signal and sends it back, and then you calculate how long it takes to get back. Or you send it there with a specific frequency, and then you see how the frequency has changed when it comes back to you. Those are two ways you can do it. But the point being is, I don't need any fancy equipment to do this, right? I just need a tape measure and our brain. Okay. You don't need fancy lasers or radar equipment, okay? Or if you're underwater, sonar. Okay, so the only difference between radar and sonar is radar sends like basically a wave, like a visual wave, and sonar sends a signal, an audio wave. They're both waves, so they're both basically the same technology. Okay. All right. How are people doing? Are you guys okay with that? Sorry, I got a little physicsy there, but I just wanted to explain everything so that it made sense with what we were going to do. Okay. So why don't we have you guys try one of these out on your own and see where you get stuck and see what we can do from there. Okay. And we're out today at 12:25, so I think we're doing just fine. So let's do another example of this. So this one's going to be a tree. Okay, so this is going to be an example that you're going to try on your own. So let's say we have a tree, and I'm a super beautiful artist, so I got my tree there. And we're going to do this one. So this one is a slightly different one. So when we had time, I used to do this in class. So another way of doing this, so if you don't have shadows, you can use a mirror. So what you do is you put a mirror on the ground between you and a tall object. And what you do is you put like a little dot on the mirror, and then you line up your eyes to the top of the tree. And according to Snell's law, I know you guys are super impressed by all my physics. According to Snell's law, an angle of reflection of a mirror, the angle of induction is the same as the angle of refraction. Ooh, gosh, so much physics today. This is exciting. So that's Snell's law, Snell. You can look it up. I'm not lying to you. Snell's law says the angle coming into a mirror is the same as the angle leaving a mirror. We're both going to assume that they're standing straight up. So now we have similar triangles. Okay. So let's say we're using the same person. So this person is 6 feet tall, and they're going to be 8 feet away from the mirror. Okay. The mirror is 16 feet away from the tree. I want to know, how tall is the tree? Okay. So again, this is just a different method of doing this. I always, when we had time in class, I always just call this the pocket mirror problem. So, and then I had mirrors that I would give people to use, and you can just take a mirror, put it on the ground, and measure the height of anything. It's actually pretty fun. Okay, so why don't you guys go ahead and find the height of that tree? And I will give you guys a little timer. So I don't think this should take longer than 1.5 minutes. So I'm going to give you guys 1.5 minutes. All right, we're going to go over this problem. And just remember, the next time you're out in the woods and you have your little pocket mirror and you're checking out how good you look because you look ridiculously good, right? That's why you're out in the woods by yourself. So just remember, you could just take that pocket mirror, put it on the ground and be like, hey, how tall is that cliff? Or how tall is that tree? Or how tall is the Great Pyramids of Egypt? Okay. Or how tall is that building? So this is a really cool way of being able to measuring things with just a tape measure and a mirror. Okay, and you don't have to have the sun, right? So this doesn't require there to be a shadow. All right, so how do we solve this? We're going to have, so I'm going to start with the side that I'm solving for. So I'm going to I'm going to solve for h. So h is the height of the tree, so that should go with the height of this person, right? And then I have to start with the same triangle, so I have to start with 16 again. And then that's going to go with, so it's the distance from the tree to the mirror goes with the distance from the human to the mirror. Does anybody have questions about how I set that up? Okay. Yeah, you guys are doing great. So again, this is h divided by 6. So if I want to get h by itself, I have to do the opposite of divide. So I'm going to multiply by 6 here. Okay. So then I'm going to have 16 over 8 and then times 6. And again, Desmos calculator does just fine. So we get the height is 12 feet. Oh man, that's a short tree, isn't it? Yeah, it's twice as tall as the human. So maybe you're high up in the mountains and you're hiking and it's an alpine tree. Right? Alpine trees don't grow as big because they're covered in snow for so long. All right, cool. So you guys are doing better. You're doing better with this. So let's go. We're going to do a couple more of these and then we'll see where we're going with this, right? So this is pretty cool. Okay, so let's do another example. We got a few more examples that we're going to do. So this one, we're going to be let's say we're downtown Seattle. All right, and we got a big skyscraper. Okay, and we don't know how high it is. We do not know how high it is. Okay. Now this is dangerous because I'm making this problem up. So give me just a second. I gotta think about this. I gotta. Okay, thinking. Coming up with this. Just a second. I gotta double check something. All right. That's true. Okay. So let's do this. Let's say. Okay. I'm gonna try. So I'm making these numbers up. So hopefully it's not too crazy. Oh, it does help me think. So what happens is that ideas they pour out of my jaw, and the beard, it stops those ideas from coming out. So I have to massage the beard a little bit so that the ideas kind of come out. Yeah. People thought it was just dandruff, but it's their ideas. They're just little ideas. Okay. I'm glad you guys think my jokes are funny, because if you didn't, this would be awkward. Okay. So I'm just warning you guys. I'm making these problems up. So let's say it's 20 feet to your mirror. Okay, so maybe you're on the other side of a road, and then it's just half a foot to a person. Sorry, not drawn to scale. Okay, so the person looks down and it goes up. Again, we're going to assume that this building is straight up. So I want you guys to find the height of the building. Okay, and then I'm going to give you guys the old minute and a half. Oh, what's the height of the person? You guys, You guys are making this too easy. I'm just joking. Yeah. How tall are we? So let's say we're 5 foot. Do I want to do that? Let's say we're 6 foot. Probably need that in there. And I just totally made this problem up. So if the numbers don't work out, then you can blame Mr. Dewey because he seems like someone who should take the blame for that. You guys are killing it. I made a really good problem, by the way. Ooh, we're getting different answers. This is good. This is good. People are getting different answers, which means we have stuff to talk about. Exciting. Hashtag excited for math. All right. So let's take a look at this, guys. We want to solve for the height of the building. So I'm going to have the height over, and then the height's going to go with the height. So I'm going to have the height over 6. I started with the building triangle, so I always have to have the building triangle on top. I have to have the 20 on top. And the 20 feet to the mirror is going to go with the half a foot, right? So you can write half a foot as either a decimal or a fraction, since it's a rational fraction, which means you can write it as a decimal. So if I wanted to solve this bad boy, I would multiply by 6 on both sides. And we get h equals, oh my gosh, calculator time. Calculator time. Maybe that song's too old for you guys, but if you've never heard of calculator time. Okay, times 6. It's kind of like hammer time, but way cooler. So I get 240 feet, which, yay, I made a great problem. So that is about 30 stories. That's about a 30-story building. Okay, so a 30-story. So how you can approximate a story? A room, usually the ceiling is 7 to 8 feet tall. So if the ceilings were 8 feet tall, then that would be 30 floors. Cool. Yeah, mental math. What? All right, cool. We got a couple more, and then we'll be good. We're just gonna practice a couple more of these and going. A couple of things I do want to say just really quick. Our midterm is going to be on. I just want to make sure I got this right. So we're gonna review for the midterm next class. So your midterm, so next week we're going to be reviewing for the midterm. So we're going to be reviewing next week the 26th, the 27th, the 29th, and then your midterm is going to be on 4:30. Okay? So if people are planning for that, your midterm test is going to be next Friday. Okay? We're going to take that in class. Crazy town, right? You guys super excited about that? So next Friday, we're going to be taking our exam. Yep, it's just like all your other exams. It's open notes, and you can use a calculator. You won't need time out of class. You won't need time out of class. It's just like regular school, guys. Like just like before, we read a test so that it can fit class, and you'll be totally fine. So you won't need how many questions? Well, there's like at least 20 million, but it only takes 30 minutes to take the test. So Guys, like, don't freak out. Like you're assuming I'm a terrible person and I would write a test where you didn't have enough time to finish it. The test is designed to take 20 to 30 minutes, and you're gonna have 55 minutes. So even people who are like, "Crap, I'm a slow test taker." Cool, take your time. You'll have enough time to complete the whole test during class. At least 80 questions. Oh my gosh, are you joking? It's gonna be no. It's not gonna be 80 questions, guys. It's a test that takes 20 to 30 minutes. So don't stop asking about questions. It's gonna take 20 to 30 minutes. Okay, because some questions go super quick. It's like, what is your name? Okay, that goes really quick. Okay, other questions take a little bit longer. So asking how many questions isn't a good. Do people time it? No, guys. It's just, how did you take tests in class before COVID? That's what it's gonna be like. We're gonna show up to class. You're gonna take a test. You're gonna be done by the end of class. That's how it's gonna be. Sometimes I forget my name too. Luckily, it's open note, so I would just make sure your name is in your notes. Okay. All right. Let's do another one of these. You guys are freaking out. I didn't mean to freak you guys out. Okay. Didn't mean to freak you out. Freak you out. All right. Let's do a couple more examples here. I'm trying to do a nice, relaxed pacing for you guys. 454. All right. Okay. So let's say there is a cellular tower. Okay, so I don't know what a cellular tower looks like, but let's say there's a. Ooh, you know what? I'm gonna have you guys draw your own picture. Yeah, that's what I want. Okay, so I'm going to go like this. I'm gonna zoom in because obviously that is too far. There we go. I'm gonna go like this. Oh my gosh, my picture is in the way, so I'm gonna move my picture. And then I'm going to autofocus. And then I'm going to freeze. And then I'm going to move all of this so it's not wobbling. And then since this one doesn't have a picture, I'm going to give you guys a little bit more time. So I think 2.5 minutes is good. And then I'm going to start the timer. All right, so let's go over this. I'm just gonna go here and just do it on this page. So it says a cell phone tower. Ooh, there's my cell phone tower here. Maybe I can cell phone tower there. And it here, I can make straight lines. So it casts a shadow, and its shadow is 72 feet long. Okay. And then a nearby, I can't read. A nearby tree that is 20 feet tall. So here, let's go. Let's see this. I'm going to have a nearby tree. Okay, so there's my tree. And it's 27 feet tall. And it casts a shadow 6 feet long. Okay. So, right, and these are 90 degrees. And I'm going to do and like that. That's not too bad, huh? Okay, and we want to know the height of that guy. So to do this, I'm going to start with what I'm looking for. So I'm looking for x. So x is going to go with the height of the other one. And then since I started with the triangle with the cell phone tower, I need to start with that again. So 72 over 6. Okay. I do have to say my drawings are pretty amazing. I thought about I was going to quit being a teacher and become a digital artist. Yeah. I mean, because digital art is all the craze now, right? Famous people are selling digital arts for hundreds of thousands. So, maybe that's I'll start memeing and I'll make a lot of money. All right, so to solve this, again, it's x divided by 27. So I'm just going to go ahead here. I can change the color. So I'm going to go ahead here and I'm going to multiply by 27 on both sides. Right, that's going to cancel out those. So I get x equals, and then on my little calculator, not to be like saying see you later, but I might calculator, I get 324. Ooh, that's a terrible 324 feet. Uh-oh. Someone has a question. What's the question? Oh, is it just because my 3 was so bad? So x equals 324. Okay, so again, I just multiplied both sides by 27. And in my calculator, I'm typing in what I just circled right there. Okay, does anybody have questions? Okay, well, then I got one more problem for you guys, and then we're going to talk about what's going to happen the rest of the next couple of days, and we'll go from there. All right, so this next one is a picture. Ooh. If you do, just remember that all this is on YouTube. So if you miss something, you can check it out on YouTube because there will be announcements at the end of class. Okay. So let's go here. I'm going to unfreeze. And then I'm going to... Ooh, there's a train. Choo choo! But what I really want... Tell me what you want, what you really, really want. Oh, I want to find the height of this globe. Freeze. Okay. They call me Mr. Freeze. That's not a very good freeze. Okay, here we go. Let's reset the timer and let's have a go at this. So let's find the height of that globe. You can see the person's little handy pocket mirror laying on the ground, right? Got to make sure your hair looks good in public. It's easy for me because I don't have a lot of it anymore. People are like quick on the draw. They're like, crap, this is so easy. Well, I'm glad you think it's easy. That means that you are learning and you can go impress all your friends. Right? They're going to be like, man, if only I knew how high this was. You're going to be like, well, look, throw down your pocket mirror and be like, let's find out. Yeah. Your nickname will be Pocket Mirror. Oh my gosh. If your friends get angry when you start talking math to them, then maybe we should really start considering who your friends are. You know what I mean? Maybe you have your normal friends over here to the left, right? The normal friends. But then you have your real friends over here to the right, you know, who are fixing their glasses. They got their pocket protector and they're like, yeah, I measured the height of that last week for my friends. Yeah? Those are your real friends. Right? I know I just was making fun of geeks, but I am kind of a geek, so I was just making fun of myself. If you guys want to talk math, you can always talk math with me. All right, so I want to find the height of this globe. So I'm going to start out with the height, and I'm going to say the height over. Now the height's going to go with the height. So in this case, my person is 5.6 feet tall. I'm going to set that equal to, so I started with the height of this, so it's 100 feet, right, to my 4 feet from the mirror. Oof, come on. There we go. Okay, so again, to solve this, I think we're seeing a pattern. This is h divided by 5.6, so I'm going to multiply by 5.6 on both sides. 5.6 goes away on the left. I got to grab my calculator, right? They used to always, my teachers used to always say, you got to do this in your head because you're not going to have a calculator in real life. Well, it turns out cell phones happened. So take that, Miss Schrimmer. I'm just joking. I never had a teacher named Miss Schrimmer, but in my mind, it was a good story. Okay, let's take a look. So I end up getting that the height is 140 feet. Okay, and that takes us to the end of our lesson. Don't leave just yet, just so you guys know. So tomorrow we're going to have practice time in class to do this assignment. So I'm a little worried because not a lot of people turned in, like only about half of you turned in the assignment from last class on Tuesday where we had the whole class to do it. So make sure if you guys don't finish up that assignment in class, you have to finish it up by the next class. So again, tomorrow's a work day. So we're going to work on stuff and it's going to be due Monday. So if you don't finish it in class, you need to get it done by next class. If you guys need help, remember I have office hours from 8:30 to 10 in the morning. That is class. Goodbye, everybody, and enjoy lunch. Bye, guys. Yeah, take care, guys. Oh, tell me what you want, what you really, really want.